All right, so this is section 1.1. We're solving simple equations today. And, well, really, we're just kind of solving equations that are one step, perhaps two steps. And the first equation we're going to look at today is right here. Solve this equation, x minus 7 equals negative 6. So one big thing about solving equations is understanding, like, we need to sometimes do the opposite. We need to cancel things out. And we want to understand what canceling things out means. So as we look at this equation, what should we do to get x equals, right? The goal for this whole thing is to get x equals some number. We don't know what that number is, but we want x equals some number. That's how we solve the equation. So we're trying to find the unknown. What would be our first step in this red underlined equation? Sophie. Very good. So we need to add 7. So you're right about add 7. So what I want to do is I want to think back to a balance beam. I want to add 7 here. And where else do I want to add 7? I want to add 7 here on the left and also on the right. Perfect. Kind of like a demonstration you might have seen where there is a scale and we're balancing it out, right? If we put 7 pounds on the left side of a balance and we put 7 pounds on the right side of a balance, it will still come out balanced. Agree? Okay. Big deal here is, what does negative 7 plus 7 actually equal, Riley? 0. Perfect. So because that equals 0, we now have 0 here, and we have x here. So we have x plus 0 equals, and what is negative 6 plus 7? Cadence. 1. Perfect. So this is what we have for an answer. But the thing is there a way we can simplify it? Is it necessary to write it exactly like this? What do you think, Lily? You can just have plain old x equals. And what does x equal? 1. Okay, let's make sure it makes sense. I mean, we had an equation that said x minus 7 equals negative 6. So if we go ahead and we take our answer, which was 1, and we put it here, 1, and we take away 7, 1 minus 7 equals negative 6, is that true? Is it true? Yes, it is. So what we know is this is called checking our equation, and now we know that we have the right answer. All right? Do we feel comfortable with example 1? Okay, let's cruise on down to example 2. Now, example 2 is really not a whole lot different. It's just there's one thing happening here, and that is that there are decimals going on here in example 2. You follow me? So don't worry about it. I mean, it is annoying, but we can handle it. We have y plus 3.4 equals 0.5. Tell me, someone, what do we want to get rid of? Get rid of is the word I'll use. Get rid of. Eva? Exactly. We want to get rid of this adding 3.4. If we were, so we have this plus 3.4, and we want to use minus 3.4, right? Minus 3.4. So I'm going to use a minus 3.4 here, and if I've done a minus 3.4 on the left side of the seesaw, what do I have to do to the right side of the seesaw tray? I have to. I cannot keep the, otherwise I can't keep putting this equal sign down. You know what I'm saying? I'm going to bring this equal sign down and say it's equal, but it's not going to be equal if I have done different things to one side and the other. You know what I'm saying? Now everything's balanced, just like when we had that balance beam demonstration. So what is 3.4 minus 3.4? Yes, Cadence? 0. Do I need to write it? We wrote it the first time. Do we need to write it this time? Should I write 0? No, I don't need to write 0. So I'm going to go ahead and cancel it out. Okay? But we understand why we're canceling it out, right? That's very important. Very, 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 very important. Okay, we got 0.5 minus 3.4. So what do we do with this situation? Anybody have any ideas for this one? It's kind of annoying of a number. It's decimals. How do we handle it? We subtract and we keep the sign of the higher number. Is this going to go negative or not? Is it going to go negative or not in the end? Yes. It's going to go negative because the number is negative 3.4 is so big, it's going to make it go negative. Okay? So we got 3.4, and we want to take away 0.5. That's what's happening. We got to borrow here, right? I got 14. That's supposed to be a 14. My apologies. Let's go back and fix that. That's a 2 we borrowed. We have 14 here. Is this how you still do the math? Yes? Does this sound right? Okay, cool. Because I know sometimes they teach you some weird stuff these days. Okay, so 2.9, yeah? So do we agree that it's negative 2.9 here for our answer? Feeling comfortable? Yes?
So I thought when you had subtraction,
Okay, so with addition and subtraction of positive and negative numbers, you're going to need to think of it like a bank account. And if you're taking out more money, $3.40, but you only have 50 cents in the bank, where are you going to go? Positive or negative? You're going to go negative, right? So it's not really about switching the signs. It's really about whichever sign is larger, it's stronger, and that's where you're going to wind up. You know what I'm saying? Like, if you have $20 in the bank, but you have to take out 100, is it going to go negative or not? You have $20 in the bank, but you got to take out 100. Yeah, because the 100 that you're taking out is so much more than the 20 that's in. It's going to go into the negative, right? But of course, if you have negative $5 in the bank, and now you're depositing 500, are you going to go positive? You had negative 5. You overdrafted. They sent you a letter. They're mad. But you're now putting $500 in. Are you going to be positive or negative at the end of the day? Positive. So it's really whatever number's larger in addition and subtraction is the sign that you keep. Right? Yeah, and there's a rule. They say subtract and keep the sign the higher number. That's what a lot of people say. But if you think about it from a banking perspective, right? Yeah? Got to be a good banker. Okay. Let's move on. Let's try something different. Nope, we're going to keep going. Nope, we're going to keep going. Okay, oh wow, they really made it happen on this one. Okay, so our next example has to do with this right here. Now, this is tough. Don't miss that negative sign out front. There's a couple ways to handle this problem, okay? I'm going to be honest with you. There's a couple different ways to handle it. So what are your thoughts? Does anybody have any ideas out front? And I want to talk about something that's pretty important, too, about this problem that I'm thinking of now. Go ahead, Lily. So you could do 0.75 if you want. You could. It might not be my method, but maybe Trey has an idea as well. It's okay.
Change the 2 into a fraction.
You could do that too. That's another option. It's definitely a tool that's at your disposal. I want to talk about something. I'm going to go off on what's called an aside, okay? Let me explain. When you guys get to college, your professor's always going to go off on these things called asides. An aside means this doesn't really have to do with what I'm talking about, but it's kind of like I'm going off on a little rabbit trail. You know what I mean? I need you to understand something, okay? What's the deal here? Negative 3/4, negative 3 over 4, 3 over negative 4, negative 3 over negative 4. Okay, which one of these are same and what's different? What's the deal with this stuff? Cadence, thoughts?
Negative 3 over negative 4 and negative 3/4 are the same.
So you're saying that, if I'm not mistaken, you're saying that this one and this one are the same. Is that correct? Yes? Okay. Who agrees with that? Do we have any agreement in that? Yeah, a few? Okay. Who disagrees? Trey, you disagree? Tell me why you disagree.
Because there only should be one. There only should be one negative symbol of each, so I think negative 3/4, negative 3/4, and I think those are the same.
You're saying this is the same as this? That's what you believe. Do I have that right?
Maybe and the other one too, but I'm going to stick with
This one over here? Possibly. This is you're having a hard time with that one. Okay. These three then. We'll just go out on a ledge. Who thinks those three things are the same? Those three things.
No, it's the other two.
True. You are correct. When you have negative 3/4 in front of a whole fraction, that means the whole fraction is negative. For the whole fraction to be negative, either the top is negative or the bottom is negative, not both. here's the common error, okay? I'm going to do it in red so you can understand that it's an error. This is not correct. This is not right. This is what a lot of people do, right? They distribute the negative to both and they say that this is the same, right? That is not true, and it's something that we need to have a discussion about when we see it come up. Okay? Does that make sense? Do you understand what an aside is now? An aside is like, that didn't really have to do with the problem, but it was pretty important we talked about it, don't you think? So actually what's weird about this is that I'm going to change this problem to now negative 3 over 4n equals negative 2. That's how I prefer to look at the problem. In my opinion, that's the better way to look at it. Is that okay? Everybody understands what I did? Good.
Well, isn't it the same as it was before?
Yeah, I've really just written the problem a little tiny bit different. I put the negative up top instead of the negative out front, and I preferred it that way. Okay? And I prefer to always put the negative on the top when I see it like that, and you don't have to do it. You might not do it that way. I don't know. Ms. Schiavone, do you have a preference when you see the negative in front of the fraction?
I like to bring it on the top too. I almost never write my negative on the bottom.
Right. So if you consistently do that and you know the rule that the negative in front of the fraction, the negative would go on the top, you might have yourself, you might find that to be really helpful. So now the question becomes, what do we do to get the n isolated? Well, what do we hate about the problem? What's the most difficult part? Cadence. It's a fraction. So a fraction is a form of addition, subtraction, multiplication, or division. What is a fraction a form of? What is that, a fraction? Yes? A fraction is division. That is true. A fraction is division. Trey, thoughts?
I was totally just raising my hand.
Oh, okay. You zoned out. Okay, no problem. Angelina?
Well, maybe if you, because usually when we solve normal equations, we usually do the two numbers we know first. So maybe if we multiply negative 3 and 4, then we might get like that part of the problem, the answer.
Okay, you're close. So let me tell you what I'm thinking. Right here I see a divide by 4, and I don't want it there. I don't want to divide by 4 there. So if I don't want to divide by 4 there, what must I put there to cancel it out? Lily?
Times 4?
Times 4, Hannah? Multiplication of 4. So you both said times 4, multiply by 4. You're both right. If we multiply this by 4, okay, we're in pretty good shape because now I have to divide 4 times 4, yes? Okay, pick a number, any number, 2-digit, please. Don't go crazy here. Trey, pick a number, 2-digit, please. What's that? 24, okay. Take the number 24 and then multiply it by 4, okay? And then you're going to come up with an answer. I believe that actually comes out to 96, okay? Now take that 96, okay, and divide it by 4. What does that come out to? What's that?
24.
24. Something interesting happening here? Anthony, what's happening here? What's interesting to you? I multiplied by 4, and then I divided by 4, and what happened? I got the same answer, so kind of nothing happened. Would you agree? Sort of like nothing happened, because 4 divided by 4 is 1, so I'm going to cancel that out. Why am I going to cancel that out? Why am I going to cancel that out? Because 4 divided by 4 equals 1. And 1 doesn't really need to be in the dividers, right? We don't need to divide or multiply by 1. It's gone. Trey.
I might be going a step ahead, but
Go for it.
do the
Yeah, please.
4 times on the other side of the
Oh, yeah. Thank you for reminding us of that. We don't want to forget that. Because Trey, what did we do earlier today? We messed around with our volunteers here, right? And we want to make sure that the balance is always even, the seesaw. If one person jumps off the seesaw, the other person's got to jump off or else it's going to go out of balance, right? Are you ever on the seesaw and then the person jumps off? How does that feel? It hurts, doesn't it? Yeah, it's depressing. Exactly, that's right. If you're on the seesaw and the other person jumps off, it's going to go way out of whack, way out of balance. So you must do the same thing to both sides to keep it in balance, or else that equal sign cannot be written. Otherwise, you have to take this eraser and just straight up erase that equal sign. You can't even put that there because you haven't kept it balanced. But luckily, we did keep it balanced, and we can keep the equal sign there. Whew. Really?
I have a question.
Yeah, go for it.
So when you do the multiplication and division that equals 1,
Yes.
when we have addition and subtraction, it equals 0.
Yes, brilliant. I'm glad you asked that. So you're saying that basically in one situation we have x and we had something that came out to 0, and in the other situation we had some division and it came out to 1. So this is what's happening, okay? These are really kind of saying the same thing. If you take x and you add 0 to it, you just get x equals 7, right? So that's your answer. But if you take x and you multiply it by 1, well, what's 1x?
1.
Just plain old x. 1x is just plain old x. So you don't need that 1, so you get this. Do you see what I'm saying? So there's two different situations here. I'm glad you noticed that because so many students think of it as all the same thing. Every time they put a slash, they think they're doing the same thing. They killed it or something. I don't know. They slaughtered it. You know what I'm saying? But in a sense, in one situation, you're adding and subtracting and you're getting something to 0. And in another situation, you're multiplying and dividing, you're getting something to 1. Yes? And if you can understand when you're doing which one of those, you'll make a lot less mistakes because it will save you a lot of sign errors. S-I-G-N, errors, okay? Errors with your pluses and your minuses. How are we feeling, guys? I'm loving this right now. I don't know if you can tell. Okay. Yes, Trey.
Can I just finish the whole
I know I'm a slow poke here. I'm sorry. Okay, what do you got? So what do we have? We have -3. This is all gone? It's just 1 now? Is that correct? So do I have this? Is this correct? Okay, let's think about something. Really fast.
It cancels out. Or it equals 1 rather.
Right. Okay, so here's the deal. Check it out. Okay? What happens if I have this, like this 4/1 here? How do I reduce this? Divide 4 by 4, right? And what do you get? 1? Divide 4 by 4, what do you get? 1? Okay, what's -3 times 1? -3. What's 1 times 1?
1.
Okay, so do you have -3 divided by 1? Yes? In front of the n. Well, what's -3 divided by 1? -3. You follow? So it canceled out because it was really just a 1 times -3n. This being the 1. Okay, I know I've confused some people. Yes, Lily?
So then do we have to,
Don't have to show it.
you normally have to cross out the other side, what's the side next to
This?
have the 3/4 not be there anymore. When you do that,
I see what you're saying. Well, unfortunately, we only dealt with the 4, we didn't deal with the 3. So we canceled out the 4, but we didn't cancel out the 3, right? Now, some people would solve this problem a different way. There's a one-step way of solving it. Now, after this way, I never did it that way. Still don't do it that way. But some people multiply by the reciprocal. Have you heard of this? Well, you can multiply by 4/3. And it cancels both of them in one step. It's a little more powerful. Yes? Okay. We're going to look at this one more time because we're not done yet. We're really getting close. In this right here, in this equation here, I think it's starting to make you a little bit tired, your brains. I can tell when that happens. Go ahead, what do you think? Give me your thoughts on this. Here. Okay, Angelina, thoughts?
so, I thought that in multiplication and division, when you have positive and negative.
Good afternoon, MHS. Your afternoon now.
Dang.
Attention seniors.
I'm just going to finish this for the video,
Register for the October.
and then we'll talk. So,
We'll start.
we don't have
minutes of math strategies followed by 30 minutes